So the screening is embedded like a core process. So you need to have a good screening, a good precise fraction size to have a very nice sorting.
In this plant we are sorting household waste, removing all the parts that can be recycled.
The system integrator has to design the process because we know what MSW needs.
After the material is fed into the line, it starts with our first screening machine doing a cut at 180 millimeters. The bigger size fraction goes into a shredder. The material, which is already small enough, does not need to be shredded. This results in less input for the shredder and so in a smaller version and furthermore into a longer lifetime. Also because it gets not the very fine material, sand, mineralic particles and fine metals. The fine fraction goes further on the second recycling waste screen, which is doing a cut at 60 millimeters. Back to the shredded material. This material goes on the third recycling waste screen. This machine also does a screening cut at 60 millimeter. Later on, there's also a flip-flow screen in the line, which does a screening cut at 15 millimeters, standing directly in front of an acceleration belt of a sorter. The mats get tensioned and relaxed, and with this movement, they accelerate the material with 50 G. The cover for the second and third recycling waste screen has a special design. So we used the belt, which is on top of the screening deck. The screening machine is fed in 180 degrees, and this has the advantage that we can connect the cover of the screen with the belt. So it's only one plane, and you can just strip it off to have a direct access to the screening panel. And another thing, when the belt gets turned, the material which is sticked to the belt falls directly on the screen and not in the plant. Because the screening deck is opened to the belt, you only have the plane at the left and then the right, not horizontally. The very first screen has a very luxury cover. We call it hood cover, and it's like a bus. So you have a very high clearance in it to get easy access. The screening machine does not only screen, it also distributes the material on the complete width. With this setup, the following sorting process does not need to have another distributing machine.
You reduce your cleaning time, you have a better overview of the material itself. The screening efficiency is way better than when you use a drum screen, for example.
And then the third dimension comes into play, and this long piece has to work against this third dimension in the screening panel. And then there comes the next circular movement to put the long piece out of the hole into the coarse fraction where it should be.
You save the long parts, you don't have that in your end streams, and that is really a disadvantage of the drum screen.
The 3 recycling waste screens are standing on air pressure springs. This solution is patented. And it has a big advantage that it's not only some tumbling out when you shut down the screen, it also has a real brake function. So the screen gets much more quicker into still stand compared to different solutions. For the surrounding construction, it's a big benefit because, as you can imagine, as less the vibration go into the steel, as better the lifetime. We have modular screening panels which are fixed by screws, so it's very easy to exchange them. The guys from Banzo included us in the whole process, so it was a really partnership-wise way of working. We had several meetings about how to choose the right screens, the right screening cuts, and it was always focused on the best solution for the customer.
This plant means a lot to Tekniska Verken. It's the next step to being more resource effective. It's a rapid process and we are in the future with this plant.
Best screening, best sorting.